Alaikum. I am Ali Mazin from BITC.
Hi, my name is Zixing. You can call me Eric.
Assalamualaikum. Hello everyone, I'm Nohuda binti Zakaria from 1 BITC, Faculty of Communication and Information Technology, UTM Malacca.
Today I am going to explain MIPS. What is MIPS? MIPS is Instruction Set Architecture, a low-level program language which deals with register and memory addresses. MIPS stands for Microprocess Without Interlocked Stages. MIPS syntax. The MIPS syntax is too simple to write. It is written as follows. Operation. Register 1, register 2, register 2. This syntax means register 1 equal register 2 value operation, register 3 value. For example, add register S0, register S1, register S2. That means register S0 equal register S1 plus register S2. Operands. MIPS operands must be registers only. MIPS has 32 registers. MIPS word is 32 bits, 4 bytes. Every MIPS register holds 32 bits, thus mean a word. A word doesn't mean string, it means base of data. Problem. Create a program to be run in Q2SPIM, which is allowed user to input 10 random numbers. After user entered numbers, the program should be able to display the numbers that have been exceeded order, the sum of the entered numbers, the average of the entered numbers, the median value for the numbers. And now we are going to explain our code how to works. Now I put the numbers 0, 4, 1, 10, 6, 2, 7, 8, 11, 9. This is the program to output. The number entered is exceeding order is 0, 1, 2, 4, 6, 7, 8, 9, 10, 11. The sum of all entered numbers is 58. The average of the entered numbers is 5.8. The median value for the numbers entered is 6.5.
Now I'm going to show you the coding part of our program. So firstly, we have to do data declaration. To do that, we have to write .data. After that, we have to write all the elements that we want to use in our programs. So firstly, you have to write a name for the functions, prompts, followed by the operations, the code, .ASCIIZ. For this code is that to allow our programs to print out a string. This is the string that we want to print out in our program later on. Here are all the strings that we want to print out using the same code, but different function name. So later we can just call the function to print out the code. So for the last code is slightly different, array, colons, dot space 40. For this code means that we declare 40 bytes of storage to hold the array of 10 integers, because each integer holds 4 bytes. After that we proceed with our main functions after we do all the declarations. So to do the main functions, we have to write .text, .glbl main, followed by main colons. Firstly, we want our system to print out the first line of the code. So to do this, we write li register v04. This one is the code to print out string, followed by la register a0 prompts. This one is to allow the program to print out the words in these functions, followed by system call, meaning that we want our program to print out immediately. These three things is to allow our program to print out this string immediately. Following by ori register t5 0. This one is that we load 0, number 0, integer 0 into register t5, and we load integer 0 into register s2. After that, we initialize register s1 by array, means that we want s1 to become array. Following part is the loop. Loop part is that we want user to input 10 integers. So for the first code is that we want to allow our system to read the integers typed by users using this code. So system call means that we want system to do this immediately, to read out the integers that user type. Following by store words sw, register v0 into 0 address of register s1. For this code means that we want to store the user input into address 0 of register s1. addi register s1 by 4. Here means that we increment the array of address by 4, following by register t1 by 1. This one means that we add register t1 by 1. This one is for the counter of this loop. Be not equal means that if t1 not equal to 10, then it will continue to loop. Means that it will loop until t1 becomes 10. Only we will proceed down. So t1 began with 0, then it will increment by 1 until 10. Means that it will loop for 10 times. And store the address, store the user input into different address, because we increment the address of s1 by 4 each time. After that, we initialize the array into register S1 again because we already changes the user input. Here with user input, we want to store again into register S1. After that, we reset the T1 into 0. We minus T1 by T1, means that we reset T1 register to 0. Following part is the order function. Order function we have separated to 3 parts: order 1, order 2, and order final. For this 3 part is that we want our program to set the random numbers that user input into ascending order. So first code be not equal, means that if T2 not equal to 9, BEQ means that be equal. If T2 equals to 9, it will proceed to order 2. So for the first code, we load the address in register S1, 0 address in register S1 into register T3. Then we load register S1, address 4 of register S1 into register T4. Then we increment the address of the array S1 by 4 each time. Then we increment our counter looping by 1 each time. For this code, LT, T3, register T3 and register T4, meaning that we want our program to loop, meaning that if just now we load the integers that user input in the array, we load it in the register T3 and T4. So now we compare the register T3 and T4. So meaning that the lower number will move to front and the higher number will move to back to make it become ascending order. So if you do this, the number will keep exchange until the looping become 10. It means you exchange for 10 times. Then we store again the register value into different address. After that, be not equal means that if T2 not equal to 9, it will proceed with order 1. Means that you loop for 10 times from 0 to 9. If the register T2 become 9, then it will proceed with order 2. Order 2 is that just now we already exchanged the numbers in the array registered S1. So now we have to initialize again. After that, we increment register T1 by 1 and we increment register T2 to be equal with register T1. Means that if register T1 equals to 1, register T2 will follow register T1 numbers. Means that if T1 equals to 9, T2 will eventually equals to 9. After that, be not equal, means that if register T1 not equal to 9, then it will proceed to order 1. Here means that we want the looping keep on going until all the numbers are in ascending order. Here, after the looping, then we increment, we load the words. This code is to allow our program to print out string, just like the front part. This one is the code for print out string, followed by this code LA register A0 from 1 is that we want to print out the string in from 1. System call means that we want to print out immediately. After that, we initialize the array into register S1 because just now we already set the number in ascending order, and we want to initialize again the array into register S1. And we substitute T1 by T1 means that we reset our looping, we reset the counter of looping to 0 again. The order final is that we want to print out the number just now we exchanged in ascending order. We want to print out to allow user to see it. So for this code is to print out integers li $v0 1, following by load words A0 0 address 0 in register S1. We load this address into A0 and we print out system call. Then we increment the address of S1 register by 4 and we increment our looping by 1. So for this code is that we want to print out a string of space, meaning that we want our number 10 number to have a spacing in between, so we're using the code space. After that, system call to print out the space. Be not equal if T1 equals to 10. If T1 not equals to 10, it will again proceed to order final, meaning that it will also look for 10 times until T1 equals to 10. And each integer have a space in between. Following by substitute T1, we set T1 again to 0 because we will use T1 again later on, and we want to initialize register S1 again because later on we'll use it.
Okay, now we continue with sum. First, we load the value of the element array 0 to the register T5. Then we add register T5, register S2, the value of the register T5 and register S2 we store in register S2. Add immediate register S1, register S1. For the code is to move the pointer to the next position. Then add immediate register T1, register T1, register 1. This is the repeat process. If the register T1 not equal to 10, it will continue to sum. Branch on equal. Branch on equal to sum if register T1 not equal to 10. Load immediate. Register V0 for load address, register A0 sum syscall. This code is to print the sum into the console. Then remove register S2 into register A0. Load immediate register V0 1 syscall. This to print the sum into the terminal. Subtract register T1, register T1, register T1. This code is to set the register T1 equal to 0. This code is to initialize register S1 with the address of array. Average. Load immediate register V0 for load address register A0 average and syscall. This code is to print the average into this console. Add immediate register S3 10. This to set the register S3 equal to 10. Then we divide register S2 with register S3. Move from low register S3 as a quotient. Move from high register T4 equal to remainder. Then we move register T3 to register A0. Load immediate register V01 syscall this system to call code for print integer. Load immediate register V0 for load address register A0 dot syscall this to print the dot. Then we move register T4 to register A0. Load immediate register V01
syscall. This code is to print the value of average into the console. We continue with median. Load immediate register V0 for load address register A0 median syscall. This code is to print the value of median into the console. Load word register T6 16 register S1 is to load word into the register T6, and then load word register T7 20 register S1 is to load word into register T7, and then add register T6 register T6 register T7. This code is the operation of addition T6 plus T7, and then addition immediate register S4 2. This code is to set the register S4 equal to 2. Divided register T6 register S4, that means register T6 divided by register S4. This is move from low register T3. This code is for coaddition, and then move from high register T4 is for remainder. Mul register T4 10 is the operation of multiplication between register T4 multiply 10, and then divided register T4 2. This code is the operation between T4 divided by 2 equal to register T4, and then move register A0 register T3 is to move integer into register A0, and then load immediate register V0 4 is to print the string, and then load address register A0 dot is to print dot on the terminal. Move register A0 register T4 is to move integer T4 into the register A0, and then load immediate register V0 1. This for call the code for print the integer, and then easy. Load immediate register V0 then that means call code for terminate, and then syscall dot and main